Well, good day, everyone. We're starting Chapter 2 in our Big Ideas textbook. And Chapter 2 is all about quadratic functions. And it's a short chapter. We're just going to look at a few lessons here. And the first one, 2.1, on transformations of quadratic functions. And we're going to look at the vertex form. As you can see, it is right here. It looks just like the absolute value vertex form. And we're going to be just doing the same kind of thing as we did with those absolute values, describe the transformations, and even write transformations. First, let's go and look at a little cartoon. This is the In the Bleachers. Whoa! Don't try to be a hero. It's too late for Dan. Let this be a lesson. Do not leap into the bleachers after scoring a touchdown. Apparently all the lady fans attacked him. He's gone. He's never to be seen again, apparently. All right, well, let's look at our quadratic functions now. So we have in our notes for quadratic functions the parabola, and it's called the parabola for the shape of the function. It's a U-shaped graph. That's what we know these quadratics are. The function is the x squared graph. As you can see there's the parent function, y equals x squared. We have the square up here in the actual vertex form of it as well. So that's what we see here, f of x equals x squared. These are the x squared functions, but the shape, the U shape, is called a parabola. So for your vocabulary, for the quadratic function, you could just say it's the x squared function, and for parabola, you can just write down right there, the U-shaped graph is what you could write there for that one. And then this core concept is about the translations, where it's just going to be shifting. As you can see here, it's very clear. Your black one here is the parent function, and then the blue and the red ones are shifting left and right. That's when you have an H number. So you can see there's your parent function. When you have an H number, it's going to cause it to shift left or right. And it's always the opposite of what it looks like inside here, just like it was with the absolute value symbols. Now it's in a parenthesis being squared. And so that's the left or right shift. And then you have the up and down shift. That's the K number. It's going to be always the one there in the back. So behind the function, it's going to shift it up and down. So our black one there is the parent function. And then just moving it up would give us the blue one, and down would give us the red one. And we can see that's all it's doing. The shape is still the same. As you can see, they're like parallel to each other. But the position is changed. So from the parent function. So remember, your K is always behind the function. It's not inside where X is. It's not in the parenthesis. It's outside of where the parenthesis would be. It's behind the function. You can see on this one, here H is inside the parenthesis. K is found outside the function. So make sure you're very clear about that. All right, we can go at the other two transformations here. We got our reflections and then our stretching and shrinkings on this core concept. So your reflections here, it's really important that you understand which axis reflections in the x-axis. That's clear. You want to make sure you highlight that. That's a vertical flip. You want to write that down where you're flipping it vertically. And so what that vertical really means again is you're going to, whatever it is, it's going to be on the outside of the function, or you're going to do it to the outside of the function. In this case, it's a negative sign. See how the negative is getting multiplied right there to the outside of the function, to the outside of where x squared is. And so then you can see there it's just x squared, negative x squared is what would simplify to, and it's flipping over the x-axis. But if it's a reflection in the y-axis, that would be a horizontal flip. That's where the negative is on the inside. You can see there it is right there on the inside with the x, not in front of the f, but on the inside where x is. It would go inside here where the x is. And so now the negative is affected by the square. So you're actually squaring a negative, which would become a positive. So as you can see on this one, when we had this one, when we squared, the negative was not affected by the square at all. So it didn't change. It stays negative. But when you are affecting that negative by the square, you're changing it to a positive, because negative times negative is positive. And so if that's the case, it remains right there, y equals x squared, just like the f of x was up here, x squared. So it doesn't look any different. It doesn't really change. It flipped over the y-axis, but it just flipped on top of itself. So it stays the same. Then you have your stretching and shrinking. You got horizontal. Remember, now we're going to have an a number here. So this is all about the a term. And when the a term is negative, you have your reflections. When the a term is another number other than 1, you're going to have stretching and shrinking. So now for the horizontal ones, that's going to be where the A number is on the inside where X is. You can see it there. A is on the inside where X is, just like it was with the negative sign on this one with the horizontal flip inside. And so that A number is affected by the square there, just to make sure you understand that. And so we're going to be stretching or shrinking this, so you could see it's going to be going some kind of direction here. It's going to be stretching or shrinking. The vertical stretching and shrinking is when you have the A number on the outside, you're multiplying it there on the outside. Again, you're seeing stretching and shrinking going on here. The shape is changing when you have stretching and shrinking going on. So that's what we want to make sure you understand there. And one thing to remember about the horizontal stretching and shrinking is that the number inside here is always the reciprocal of the factor number that it says. So that's why, you see the blue one here on both sides. On this one, it's a stretch right here. This one would be the stretch when it's greater than 1. This one here is called the horizontal shrink. So really the horizontal shrink and the vertical stretch, they're really the same kind of thing. They're the same idea. They're giving you the same type of graph. It just happens to be where your factor number is a little bit different. So that's where you're going to see that is the factor number. So when the factor number is bigger than 1, you're going to be stretching it. And when the factor number is less than 1, between 0 and 1, you'll be shrinking it. It'll be getting closer to the x-axis. But the horizontal will actually call it the opposite way. So you can see it's calling it a shrink when that's bigger than 1, and it's a stretch when it's less than 1. So when this number right here would be 2, for instance, A would be, it's more than 1, so we would call it a horizontal shrink, but the factor number, as you pull it out, would really become a 1/2. So when that factor number is less than 1, then you're going to, be kind of, shrinking. It's going to be shrinking that one. So I know these can get kind of very confusing, but one thing you might want to do is just, highlight or do what I'm showing you here. These kind of go together because they have the same A is greater than 1. These also kind of go together as well. They're doing the same thing. So these two would be the blue graphs that are getting narrower and thinner, and these ones here would be the red ones. So I think would be even better to see, these were our red ones here, and then these are our blue ones. There, you can see it like that. All right, let's move on and try some. Okay, so as we get into graphing some of these quadratics and describing the transformation, we'll notice that some of these remain the same shape as the parent function, and they just have some translations or maybe reflections. Those would be considered rigid motions. They don't change the shape, the size of our graph. So if that's the case, it is a little bit easier to graph them as long as it's in vertex form. As we can see here, we have a vertex form. So this would be considered vertex form here, where you have x squared plus 4, or even the binomial x minus 1 squared, where basically you could see your h and k. So when you just have an x squared, there's no parenthesis, the h would be 0, but there's your k and y is 4 of your vertex. So now we notice that there's still a 1 in front of all of these, which means it still has the same shape of the parent function. So the parent function is just the x squared function. So as long as it still has a 1 in front of the parenthesis here or in front of x, it still has the same shape. So there is a parent function or a parent graph pattern. And let's talk about that so it makes it easier for us to graph these. So this is always when a equals 1. So your a number in the equation is 1. It has that same pattern. And it is always going to go from where the vertex is. So you do need to make sure you identify what the vertex is, because that's where you've shifted it around some. So you are going to maybe change its location, just not its shape. And so we need to understand that first. What's the vertex? So on this one, for instance, number 1, we will note we'll notice that's going to be 0, 4. So when we actually plot our point of 0, 4, it's just going to be right up there at 0, 4. X is 0, but y is 4. So from that point, Well, then we're going to go right and left 1 unit. You can notice these graphs, they're all going by 2's though, so each box is worth 2. So if we go right or left 1 unit, so right or left 1, what we're going to do is we're going to go up or down 1. Now, usually we go up as long as it's still positive, but like on this one, number 3, it's got a negative sign in front, so instead we'll go down. So if there's going to be a reflection because of a negative sign in front of our function, we'll end up going down that 1. So right or left 1, up or down 1. Now that's the same thing as the absolute value. That has the same starting thing there, but then it changes, it shifts, because the absolute value pattern there would be just remaining that. If you go right or left 2, you go up 2. Right or left 3, you go up 3. That's what that pattern is for the absolute value graph. But for the quadratic one, it's not going to be the same. So when we go right or left 2, we're not going to go up 2. Instead, we're going to square the 2. 2 squared would be 4. That's how much we're going to go up or down. So we go up or down 4. And then we continue on. We go right or left 3. And we're going to go up. We got to square the 3. And so that 3 squared would be 9. So we're going to go up or down 9. And you would just continue that pattern. You can keep going. The next one, right or left 4. 4 squared is 16. You would go up or down 16. All right, so let's go ahead and try this number 1 so we can see what that is. So first of all, we need to say that it translates 4 units up. That's describing the transformation. Just to write out that, you can write it right below the graph here. And then we're going to graph the function. So we're going to end up graphing this function here. The vertex, like I said, was 0, 4, so we got to plot that point first. So make sure you have your point plotted there. And then we're going to go right or left, since it's the same shape, right or left 1, and go up 1 unit. So we'll go right 1 and up 1, left 1 and up 1. And then we're going to go right and left 2. So now we come 2 units, which is 1 box on this one, because they're all going by 2's here. So we go right 2, which is 1 box. We're going to go up 4. So that'd be 1. So 4 would actually be 2 boxes going all the way up there. So there it is. Go left 2 and up 4. And once we have that, we could try to go some more, but we're going to run out of space. So that's probably about it as far as we need to go. We can then just draw our parabola from that. And it's a U-shape. Just make sure you have it in a U-shaped formation. It is not a V, because this is not the absolute value signs. So don't think, well, these are all going to line up. And no, they're not supposed to. You're supposed to make a curve going up on the sides here. So make sure your graph looks like a U. Number 2, again, first thing, to find the vertex. So our H and K, so this one does have an H. The opposite of -1 is +1. Remember, it's whatever would make this inside here 0. So 1 for X would make this into 0. So H is 1, and so our vertex, oops, I started here. I should have started with describing the transformation. So before we graph it, let's go ahead and do that. Describe the transformation. We are going to translate 1 unit to the right, because that's what's happening here. When our H is 1, we're going to go right 1, and we're going to go down 3 units because the K is -3. So 3 units down. So that's all that's going to happen here. And so there it is. Our vertex is the +1, -3. So that tells us we're going to go right 1 and down 3 units to get our vertex. We're going to plot a point there. So there's our first point. It is going to open up, so everything we're going to do is going up. And so now from here, from this vertex point, we go right or left 1 and just go off of our pattern. Right or left 1. We're going to go, in this case, we're going up, right? So up 1. So right 1, up 1, and then left 1, up 1. So left 1 goes back to the y-axis and then up 1. We can do, again, go 2. So going 2 now puts us in the middle of this next box. So we're going to do the same pattern here, right or left 2. We're going to go up 4, keep going up. So up 4 puts us up to here. Now we're a little bit above the x-axis. Left 2, we're going to go up 4 again. So this is symmetrical. There is symmetry here, which means the left side and the right side are doing exactly the same thing. And then we can go even one more time. We can go 3 and then up 9. So if I go right 3 units, up 9, that puts me up to here, where at 4, I'm all the way up here at 6. And I do the same thing to the other side. Over here at -2, I'm all the way up here at 6. And so that gives us definitely a nice U shape there with those points. Make sure you draw a U, and it looks like a U. All right, our next one, let's describe the transformation. I'm not going to forget to do that first this time. So the transformation, we notice the negative sign. That's the first thing we need to say, is that there's going to be a reflection. Since it's on the outside of the function, it's going to be in the x-axis. It's going to flip down. It's going to open down, so it's going to have a reflection in the x-axis. And since it does have an h number here, the h number would really be -9, which means it's going to go left 9 units. So we're going to say translation 9 units left. So those are the two things you want to state for the transformation. And now let's go ahead and find our vertex on this one. So the h, like I said, was -9, but k is 0. There is no k back here, so we're just going to say that's 0. So -9, 0. Plot that point. So -9, 0 is right on the x-axis, just right over here. Let's go ahead and plot that point. It is going to open down, so as we go right and left 1, we're still going to go 1, but we're going to go down 1. So right 1, I'm going to go down 1. Left 1, I'm going to go down 1. Now that didn't look like I did much at all, but notice what we're going by. We're going by 3s here. 3, 6, and so on. So down 1 is not very far at all. And then if we go 2, we're going to go down 4. So right 2, go down 4, left 2, go down 4, and put those points. Just do your best at figuring out where that's going to be on these. I know it's a little hard. So right 2 still is in this one box here. Down 4 is going to go, there's 3, 4 will be a little bit below that. Do the same thing on the other side, not quite to 12, or -12. And then down 4 puts us a little bit below again. Same symmetry space there. And then if we even go another time, we can go 3, which would actually take us to 1 whole box, and then down 9, which takes us down 3 boxes. That's an easy point to put. 3 this way puts us at -12, and then down again at the same level down below there. And now just draw the U shape opening down from your points. And that's all it is. Okay, so continuing with our graphing 4 through 6. Number 4, the transformation to describe that, the only thing that's going on here is just this -7. So the only thing to say there is translate down 7 units. It's going to go down. Remember, it's not an H number. It's not inside of a parenthesis. It's on the outside, so it's a K number. K is always up or down. So it's just going down 7 units. Now, since it's the same pattern as the parent graph, we can go off of what we were talking about before. We need to know what our vertex is. So that's going to be for vertex x, the h is 0, so x is 0 for that coordinate, and -7 would be your y. That's the k number. It's always h comma k. So 0 and -7. So x is 0, but we're going to go down 7 units down to here. It is opening up, so we're going to be going up from that point. So if we go right or left 1, we're going to go up 1. So right 1, we go up 1. Left 1, we go up 1. And then if we go right or left 2, 2 squared is 4, so we're going to go right 2 and then up 4 from that vertex point, and then left 2 and go up 4 units. And then we can do one more even because we have enough space here. So if we go right 3 units, we're going to go up 9 units from the vertex. And then left 3 from the vertex, we go up 9. And then just draw your U shape from that. Remember that everything is going off of the vertex. You just keep going back to your vertex. That's your starting point to do all of that with to get these other points here. And we're going to draw that U shape. And now number 5 is a little different. It's not the same shape as you can see. This one has an A number, the 1/3 there. In fact, as we talk about the transformation, describing it, that's what we have to say. We have to talk about that transformation right there. The 1/3 is not inside a parenthesis with x like this one is inside. This one's on the outside, so that's vertical. Vertical is always on the outside. That's why this number is on the outside. It's a vertical translation. It's going up or down. Vertical is up and down. So this is a vertical shrink in this case because it is less than 1. It's 1/3. So we want to say it's a vertical shrink by 1/3. And there is the other number here, -6. It is going down 6 units. So it's also going to translate 6 units down. So that's what we need to say to describe the transformation. Make sure you're always describing these and getting used to using these words, these transformation words. So now we still want to find our vertex. It's not going to have the same pattern as this one did. It'll be a little bit different. But first, you always still need to find the vertex. That is your starting point no matter what. This one, it still has no h because there's no parenthesis here where it's like x minus h. There is none of that. So it's still 0 for the x. -6 is the y. So 0, -6 is our starting point. So that's just going to go down 6 units. It's going right there. It is opening up because 1/3 is positive. There's no reflection. So it will be opening up. So let's put our vertex point down here. Now, we could still kind of go off of this. We can do a table of values. You can always do a t-chart. And you know, you have this point 0, 6. You can kind of go off of that and say, well, if I go right 1, so it means x is 1 and x is -1, and plug that in, what would that be? So I could do that. Or write 2, plug that in, what would that be? So it's always what you can do. You can always choose your input numbers, and that's going to just be, you know, write 1, you know, go 1 to 2 to 3. You can put those numbers in to find that. It's going to be symmetry on the other side. So whatever you get for this side, it's going to be the same going up the other side. But I will kind of show you a little bit of the way we talked about with that pattern. So we talked about first going right or left 1. If I go right or left 1, it used to be we just go up 1. That's what we did here. Went up 1. But this time, instead of going up 1, we're going to go up 1 times 1/3. 1 times this number here. It's basically like 1 squared is still 1, but then we got to multiply it by the a number, the 1/3. Well, that is 1/3, so we're going to go up 1/3. That's what we will do. So if we go right 1, we're going to go up 1/3, which is not very far. So it's going to be really, really close there to that line. And then the same thing on the left side, up 1/3. If we go 2 units, right or left, so right or left 2 units, I just put R and L there for that. Right or left 2, we're going to do this. We're going to go 4 times 1/3. Remember, we used to go up 4. Well, now it's going to be 4 times 1/3. So instead of just going up 4, we got to multiply the 4 times 1/3. That would be 4/3, which is going to be 1 and 1/3. So I'm going to go 2 this way, and then I go 1 and 1/3. It's going to put me just a little bit up to here, not quite up to that next line. So I'm going up there, going left, same thing, going up 1 and 1/3. That's 4/3. And then I can do one more. I can go 3 units. If I go right or left 3, that's going to be 9, right? We normally would go up 9, but now we're going to say 9 times 1/3. We have that 1/3 there multiplying, which actually is 9/3, which is 3. So we're going to go right 3 and then up 3 units. And so we can see we'll be putting another point up there. Left 3, up 3, puts another point on the other side. That definitely gives us a kind of a bowl shape here, a U-shaped graph to be able to graph that with. And that's what we want to do, is draw your U shape. Number 6, for the transformation, to describe this one, we notice it does have a negative sign in here. So we need to say there's going to be a reflection, but since it's on the inside, it's going to reflect over the y-axis. Okay, it's going to be a kind of a horizontal reflection or horizontal flip, which is over the y-axis. We always got to say over which axis. That's the way they want the reflections done. So it's going to be reflection in y-axis, and because it's a 4 here, it is a horizontal, but is it a stretch or is it a shrink? That's the question. So we know it's horizontal because it's on the inside, but is it stretch or shrink? Well, that's where we want to see that this right here, 4, it's best to, you know, as you pull it out and you kind of see, okay, what would that be as a factor number? What factor are we actually, you know, kind of doing this by? It's always the reciprocal of this number. So 4 is really a 1/4. So it's by the factor of 1/4, and since that's less than 1, it really is a shrink. So it's going to be a horizontal shrink by 1/4. So now as we go ahead and try to graph this, you're going to see your vertex on this. There is no h because this 4 is an a number. There is no h. It's not plus some number here. There's nothing behind it. There's no k number either. So they're both 0. Your vertex is 0, 0. So we can plot that point first right there at the origin. And then for this one, we can go off of the same thing. If we start thinking about, okay, right or left 1, remember you can do a table of values. You can do a little t-chart, x, y, 0, 0, and just go, okay, 1 unit. If I plug in 1, what do I get? And so that's what you can do, and that's kind of what I'm doing here, sort of. I'm going right or left 1 and just seeing, okay, how much am I going to go up? Now, you might think, why are you going up? It's got a negative. Well, the negative is on the inside, so you're actually not reflecting over the x-axis. That would be going down. We're reflecting over the y-axis. We're still going up. Remember, that reflects onto itself, so it doesn't really change the look of it at all. So in this case, if we go right or left 1, we're going to be basically going up, you know, instead of going up 1, we're going to be 1 is going in here. we're doing this pretty much, negative 4 times 1, and then squaring it. So we're not even squaring the number. So if I go right or left 2, I'm going to do negative 4 times 2 and then square it. So it really is kind of like doing a table of values. So what would that be? That would be 16. Because I would say negative 4 squared, negative 4 times negative 4 is positive 16. So I'm going to go right 1, which is really close here, because this is going by 4s, as you can see. So if I 1 is like really close here, I'm going to go all the way up to 16 for that point. And so I'm going to put points on each side of this, on the right side and on the left side of this y-axis. So it's a very, very thin U. You know, still trying to make it a U shape, but it's a very, very thin U. All right, let's take a little break for our joke of the day. So why did the chicken go to jail? Well, because he was using foul language. Imagine that. Went to jail for foul language. Okay, so back on your vocabulary, there's a vertex and vertex form. We've already kind of discussed those. You know, for vertex, you should put this though down. It's h comma k. Vertex form, you could just write this equation down, f of x equals a, and then x minus h squared plus k. That is the vertex form. It's the vertex form kind of for the absolute value as well, just with absolute value signs instead for that one. And you may want to write this down that are in the red, the blue, and the green to show you what is h, and k talking about here. Well, the a indicates a reflection in the x-axis if it's outside here. Now, sometimes the a we found is on the inside, like we saw in the last problem. It was on the inside. That would be the y-axis then if it's on the inside. And it's a vertical stretch or shrink when it's on the outside, when it's like there. If it's on the inside, well, then it would be a horizontal stretch or shrink. The h number always is going to be indicating horizontal translation. It's going to go left or right. And the k number always indicates the vertical translation. That's always going to go up or down. So you may want to put up or down for this one, right, left for this blue one here. All right, because we need to know that as we start to write these transformations. Okay, so problem number 7 on your extra practice is consider this function. Describe the transformation of the graph of the parent function. So describe the transformation of the graph of the parent function, quadratic function. Identify the vertex. So the parent function we know is just x squared. So you have all this other stuff going on here. Sometimes you only have one transformation to describe. We've seen a couple of those, like problem number 1, problem number 4. Only had the one translation to describe, but this one actually has 4 of them. So you just kind of want to go through your checklist, go through all the different ones you have. So you need to remember what our a, h, and k are. So a is the number there in front, h is the number inside the -5 part, and k is that 7 in the back. So the a, h, and k. Now the a always has the 2 connected to it, which would be reflections and stretching and shrinking. So the question is, number 1, is there a reflection? Is it negative? Yes, it's negative. So because of the negative sign, then it's going to have a reflection, but the question will be which axis. So since it is the negatives on the outside, that's going to be flipping over the x-axis, making it open down. So it's in the x-axis. So first thing you would describe here is reflect in the x-axis. Next question could be, is there a stretch or a shrink? So that would be if the a, is there an a number that's more than 1? Yes, that's 10. So there is going to be a stretch or shrink, but the question will be, is it a vertical stretch or is it a vertical shrink? Is it vertical or is it horizontal? Well, because it's on the outside here, it's vertical. If it was on the inside, it would be horizontal. So this 10 here makes it a vertical stretch because the 10 is more than 1. So remember, if it's on the outside, it stays that number, but if that 10 was on the inside, then it would be the reciprocal of 1/10, making it a shrink. So this one's going to be a vertical stretch by 10. The next question would be about a horizontal translation, which means left or right, which is an h number. So yeah, there is an h number right there, -5, but remember the h number is not -5. When you pull it out, it really changes to +5, changes to its opposite. Just like the number in front here, if there was a number there, it would become the reciprocal. Well, this one's just going to become its opposite. So it is 5, which means positive 5 means it's going to go right. So it's going to move right 5 units. It's the third thing to describe. Then the last question will just be, is there a vertical translation? Is there a K number? It's going to move it up and down. And yes, there's also one of those, plus the 7. So since it's positive 7, it will go up. And so it's going to move up 7 units. Then it just says identify the vertex. The vertex is H, K. We know that. And so our H number we said was 5, because as you pull that out, it's not negative 5. That's an easy mistake to make. It's 5 and 7. So just 5, 7 is our vertex there. That's always the starting point. All right, we're still going to do just a couple more on the notes section, so we're not done yet. I wanted to describe some more transformations on the notes. So page 26 and 27, go back to that page. We're going to have, it's numbered 7 here. We just did a 7, but you can number it whatever you want to, or you don't even have to number it. Just a couple problems there that weren't in the extra practice that I did want to talk about. Let's see, a couple, transformation problems where you want to write a new function now. So it says, let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation 2 units up from the graph of just the x squared, which is the parent function graph. And it says, write a rule for G and identify the vertex. Okay, so the first thing we need to do is perform a vertical shrink by the factor of 1/2, which means, what that means to do is we have our f of x here. The f of x is this x squared here. So we have our f of x. What we need to do is multiply it by 1/2, which then means we're going to be multiplying x squared by 1/2, because f of x is the x squared. So it's just 1/2 times x squared. So that's just performing the vertical shrink. Then it says followed by a translation up 2 units up from this graph. So just now what we're going to be doing, the next part of this will be to just basically take this graph here that we just have. Let's call it now g of x perhaps, because we're making it g of x. We're now going to add going up, so we're going to add 2 units to that. So our final one here from this now will become this 1/2 x squared plus 2. That will be our g of x graph. So really the g of x graph here, I should actually put it like this, g of x is equal to 1/2 x squared plus 2. And then what the vertex would be of this graph, h, k, there is no h, so it's 0. The k is just 2. And then number 8 says, let the graph of G be a translation 4 units left, followed by a horizontal shrink by a factor of 1/3 of this graph here, x squared plus x. Okay, so for this one, the first thing to do, a translation 4 units to the left. This is an h number. Okay, so h here would be, if it's going to the left, h would be -4, but when you plug it back into the parenthesis, it's got to go back into the function. So we're putting this, remember we have an f of x, right? So we have f of x, but instead of x in here, what we're going to do is we're going to add 4 to this. It's going to be x plus 4. And that's because h is -4. When it goes back into the parenthesis, it becomes +4, because it's really x minus h. Remember, that's always what it is. So it's like f of x. I mean, this is what we have here, x minus h, but h is -4, so now it really is x plus 4. So we got to replace the x that's in 2 places here with an x plus 4. So we'll start off like this. We'll start off with f of x here, just to keep it that way for now. So instead of x, we're going to say x plus 4, and then that'll be squared, and then plus, instead of x, we put x plus 4 there. So we're going to square this. Now when we square a binomial, you can say x is getting squared. You can do FOIL here and make 2 binomials out of this. You can almost think of it, since there's another one over here, you can say x times x. That would be x squared, where you're squaring an x. You're going to be getting 4 times x and then doubling that, which is really 8x. And you can see that outside would be 4x, inside would be 4x. 4x and 4x make 8x. And then you're going to do 4 squared, which would be 16. So x plus 4 squared is this trinomial. It's a perfect square trinomial, we call it. And then over here we just have x plus 4 still. We need to combine like terms now. So we get an x squared. 8 plus 1 for the x would be 9x. And then 16 plus 4 gives us 20. Now the next thing says to do is a horizontal shrink by the factor of 1/3. So this is also going on the inside of the function. So basically we're going to be looking at like this, a times x, right? We have an a number there. Well, that a number, when we put it back into this, is going to flip the reciprocal of this. The reciprocal of 1/3 is really 3. So when we do this one, it's going to become 3 times x. That's what we now need to put in for the x now in what we have. So it's going to start off with, what we'll see here is x squared. So instead of x, we put 3x squared plus 9 times x, but instead of x, we put 3x. And it's plus 20. So now we can write this g function. So our g of x function will be 3x times 3x is 9x squared for the first term. And then 9 times 3x is 27x for that second term. Oops, forgot the 0 there. We still have 20 in the back. So 20 is still the back number. So there's our new function, our g function. What would the, it just says write a rule. It didn't say to identify the vertex this time because it's not in vertex form. Even though we could find the vertex, but it's not in vertex form, so it's not as easy to find. So that's all they needed you to write down for this one. Alright, so that concludes our lesson in 2.1. And you want to go on to the assignment for this, and I'll see you on the next lesson.